Evening, everybody. This is the notes for section 1.4, measure and classify angles. As we go through this, you'll notice there's a lot of things that are similar, at least some of the postulates and properties of what we talked about with segments. But now, obviously, we're talking about them with angles. So, first thing, defining an angle, what it's made of, and just some of the terminology that goes with it. So go ahead, hit pause, copy this stuff down. All right, so as it says, angle consists of two different rays with the same endpoint. You look at this drawing, you have ray AC, and then you have ray AB. They are two different angles, or sorry, two different rays, but they have the same endpoint, point A. Remember, an endpoint is actually where the ray starts. The rays are called the sides of the angle. The endpoint, that point A, that is called the vertex of the angle. That's a very important point. It's important because you use that when you're naming the angle. All right, when you name an angle, you have this little angle symbol. A lot of the times people just use this. I don't like that because it could be mistaken for an L. It just kind of blends in with the other stuff. You put that little arc in there, there's no mistaking it. It is the angle symbol. Please use that symbol. But when you name an angle, basically, you just go around the sides, always having the vertex in the middle. So here, angle C, A, B. Okay, just went around the angle. It doesn't matter which way you go around. You could go angle B, A, C. All right, so that's the first two. Some drawings, if there's only one angle at that vertex, it is fine just to name it with that single vertex, angle A. There's only one angle there, there's no mistaking, it's that one. All right, for this example, you know what? I'm going to do a separate video for the examples, so leave some space, put the drawing in there, the questions, if you want, but leave some space in your notes. I'm going to come back and do a second video for that. Okay, for this postulate, protractor postulate, basically describing how you measure an angle. Most of you, that should be pretty straightforward to use a protractor. So take a second, hit pause, copy some of the stuff down that's important to you. Take a look at the picture. All right, the bottom part here, classifying angles. This is important. This is how we name angles. Depending on their measurement, or how we describe the type of angle is, depending on their angle measurement. We have acute angles, angles between 0 degrees and 90 degrees. We have right angles, those are actually 90-degree angles. And notice that little notation in the picture. This is what you're looking for in a drawing to say, yeah, this thing's a right angle. It's a little box right near the vertex connecting the two sides of the angle. That tells you this angle is a right angle, its measure is 90 degrees. You have the obtuse angle. This is greater than 90 degrees, but less than 180 degrees. And this one that's hidden here is called a straight angle. Its measurement is 180 degrees. From this side to that side, 180 degrees. It's called a straight angle. Very rarely do we use that terminology. It's a line, okay? Again, leave some space in your notes. I'm going to do this in the example video, but just leave some space in your notes for that. Postulate number 4. Don't really care about the numbering of it, but the name. Very, very important. Angle addition postulate. Just like the segment addition postulate, you're going to see this, you're going to use this a whole lot this year. So very important. Hit pause, copy this stuff down, especially the picture. Okay, so basically the idea is, and I'm going to try to add to this drawing. No, I'm just going to do a separate drawing. The idea of the angle addition postulate, you take one small angle. They all got to be in the interior. They all got to have the same vertex for them to work. So you take the smaller interior angle, add it to the other smaller interior angle, and that will equal the entire thing. That's the gist of angle addition postulate. All right, I'll just leave that up there for a little bit. So it works the same way as a segment addition postulate. Now, for the example, again, I'm going to come back and do that in a separate video. Please leave some space. Okay, for this page, congruent angles. You know, again, the first sentence there describing what a congruent angle is, that's important. The rest of this sentence here, oops, that's the eraser. The rest of the sentence here, not as important. It's kind of already drawn in this box. So, take a second, copy this stuff down. It is very similar to what we talked about with segments. You name the angle. If you're talking about an actual measurement, it equals 50 degrees or something like that. You use this little lowercase m just before the angle symbol. Measure of angle A is equal to measure of angle B. Again, measures, we're talking about numbers. When we say angles are congruent, we use the congruent symbol. We just name it. Angle A is congruent to angle B. And just like with segments, being congruent means they're going to have equal measurement. If they have equal measurement, it means they're going to be congruent. And the other thing that is important that you will see a ton this year is that little symbol here. These arcs inside of the angle right near the vertex. You see this arc in a drawing, you see this pair of arcs here, it means these two angles are congruent to each other. All right, just like with segments, sometimes you're going to see 2 arcs, you might see 3 arcs. Any angles with the same number of arcs, those angles are congruent to each other. All right, for the bottom part here, an angle bisector. And again, it's a terminology that a term that you're going to be hearing a lot throughout the year. Take your second, hit pause, copy this down along with the picture. Okay, bisector basically just means it's cutting something in half. If it's an angle bisector, it's cutting an angle in half. So, in this drawing here, as it says in green, ray BD is the angle bisector. It is taking angle ABC, this whole angle here, and it is cutting it into 2 equal parts. It's cutting it in half. All right, that's the end of the notes video. Don't forget to watch the examples video.